What if in a single moment, every person on Earth pointed a laser at the moon? Not just any lasers, but the kind you can buy at the corner store. The ones kids use to torment cats and professors use to highlight important points on PowerPoint slides. 7 billion beams of light, all converging on that pale disk hanging in our night sky. Would we paint it red? Would anyone up there even notice? Let's start with the basics. Your average laser pointer pumps out about 5 milliwatts of power. That's roughly equivalent to the energy of a falling snowflake hitting your hand every second. Not exactly world-ending stuff. But multiply that by 7 billion people, and suddenly you're looking at 35 megawatts of pure focused light. That sounds impressive until you realize that about the same power output as a single wind turbine on a breezy day. The moon, meanwhile, is already getting bombarded with 37 million megawatts of sunlight every second. Our collective laser assault would add about 1/10,000% to that total. It's like trying to heat up a bonfire by breathing on it. But here's where things get interesting. The moon is, on average, 384,400 kilometers away from Earth. Light takes about 1.3 seconds to make that journey, which means our laser beams would need to stay incredibly focused across that vast distance. Except they won't. Even the best laser pointers spread out over distance, a phenomenon called beam divergence. By the time your little red dot reaches the moon, it's not a dot anymore. It's a circle several kilometers wide. Those 7 billion individual points of light would blur into a dim, reddish glow spread across thousands of square kilometers of lunar surface. Of course, we're assuming everyone can even hit the moon in the first place. You ever tried to hold a laser pointer perfectly still? Your hand shakes, your pulse makes tiny movements, even your breathing shifts your aim. Now imagine 7 billion people trying to do this simultaneously. Half of them would probably miss entirely, their beams sailing off into the cosmic void. Another chunk would hit the moon for a fraction of a second, before wandering off to illuminate some unsuspecting crater. The actual number of lasers consistently hitting our target would be dramatically lower than our theoretical maximum. And then there's the atmosphere. Oh, the atmosphere. That thick blanket of air that keeps us alive also loves to mess with light, scatters photons, absorbs energy, and generally makes a nuisance of itself when you're trying to shoot lasers at celestial bodies. Red laser light, which most pointers use, gets absorbed and scattered by water vapor, dust, and air molecules. By the time our beams punch through the atmosphere, they've already lost a significant chunk of their power. It's like trying to throw a paper airplane through a hurricane. But let's get crazy for a moment. What if we upgraded? What if instead of store-bought laser pointers, every person wielded a 1-watt laser, the kind that can burn through paper and pop balloons? Now we're talking about 7 gigawatts of power. That's enough to run a small city, all focused on our lunar neighbor. The moon would definitely notice this, sort of. The side facing Earth would warm up by approximately 1/10,000,000th of degrees Celsius. You'd need incredibly sensitive equipment to even detect the change. Moths have a bigger impact on porch lights than we'd have on the moon. The real question isn't whether we could affect the moon. It's whether anyone would see it. Surprisingly, the answer is yes, but not in the way you'd expect. If everyone turned on their lasers at exactly the same moment, the collective glow from Earth's surface would be visible from space. Satellites would detect this sudden burst of coherent light emanating from population centers across the planet. It would look like Earth had suddenly developed a case of laser acne, with red spots blooming across continents. The International Space Station astronauts would have front-row seats to the most coordinated and pointless light show in human history. For observers on the moon, if there were any, the view would be even more interesting. They'd see Earth suddenly sparkle with billions of tiny red points, like a disco ball made of rubies. The beams themselves would be invisible in the vacuum of space. But the moment they hit lunar dust, they'd create a faint, shimmering aurora across the surface. It wouldn't be bright enough to read by, but it would be noticeable. A ghostly red fog rolling across the sea of tranquility. But here's the beautiful irony of it all. The most visible effect wouldn't be on the moon at all. It would be here on Earth. Picture it. 7 billion laser beams creating luminous pillars stretching from the ground toward the heavens. In areas with dust or light fog, these beams would be brilliantly visible, creating a forest of red light reaching toward our celestial companion. Cities would look like they were firing photon weapons at the sky. The photographs alone would be worth the effort. And that's the real magic of this thought experiment. Not the negligible warming of lunar regolith or the imperceptible increase in photon flux. It's the image of humanity united in a singular, silly purpose. 7 billion people, all pointing their little beams of light at the same target, creating something that's simultaneously meaningless and magnificent. We wouldn't move the moon, we wouldn't paint it red, and we certainly wouldn't leave any lasting mark. But for those 1.3 seconds it takes light to travel from Earth to Moon, we'd all be part of the same ridiculous, wonderful joke. And sometimes, that is enough to make you wonder what else we could accomplish if we all pointed in the same direction.